In this question, we're asked to calculate the compliance of the amplifier shown in the figure, and we have to determine the type of clipping that the circuit would most likely experience. Well, the compliance of an amplifier is the limit that the output circuit places on the peak-to-peak output voltage. If the compliance of an amplifier is exceeded, clipping occurs. The AC load line of an amplifier is used to determine the amplifier's compliance. First, we need to determine which way we will calculate the value of the emitter current, IE. We do this by calculating the value of the DC current gain, given by HFE, by the emitter resistance, RE, and comparing it to 10 times the value of R2. When we apply the appropriate values, we can see here that the DC current gain times the emitter resistance is not less than 10 times the value of R2. So we proceed as follows. Step 1 involves the calculation of the voltage at the base of the transistor, or VB. This is calculated using the potential divider formula, as VB is located between VCC R1 and R2 ground. Step 2 involves the calculation of the voltage at the emitter of the transistor, or VE. This is calculated by subtracting 0.7 volts from the value we got for VB, or the voltage at the base. Next, we calculate the emitter current using Ohm's law, which is the emitter voltage divided by the emitter resistance. Here we are going to assume that the quiescent collector current, ICQ, is approximately equal to the value we calculated for the emitter current, IE, which in this example is equal to 2.77 milliamps. The next step involves the calculation of the quiescent collector emitter voltage, or VCEQ. This is obtained by subtracting the voltage dropped across the collector and emitter resistors from the supply voltage VCC. The next step involves the calculation of the AC resistance in the collector circuit, or RC. This is given by the parallel combination of collector resistance and load resistance. With respect to the quiescent collector current, the output compliance is equal to twice the quiescent collector current multiplied by the AC resistance in the collector circuit. With respect to the quiescent collector emitter voltage, the output compliance is twice the quiescent point value of VCE. Since the value calculated for twice the quiescent collector current times the AC resistance in the collector circuit, or 2 times ICQ or C equaling 1.3 volts, is less than the value calculated for twice the quiescent collector emitter voltage, or twice VCEQ equaling 3.56 volts, the circuit has an output compliance, or PP, value of 1.3 volts and would most likely experience cut-off clipping.